In this section, you're going to learn how to write automated tests for your Angular 2 apps. Whether you're an absolute beginner or have some experience in automated testing, I'm going to take you from the ground and teach you how to write automated tests for your Angular apps. So I'm not assuming any prior knowledge of automated testing. So we're going to start with a quick introduction to automated testing, its benefits, when to use it and why. Then we're going to look at different types of automated tests, their pros and cons, and then we'll get into the mechanics. We're going to start with a few simple examples, and then as you go through this section, the examples get more and more complex. These examples are based on the patterns that you see in a lot of real-world applications. So for each pattern, I will show you what you need to test and how to do it. Next, I'm going to show you how to find out how much of your code is covered by tests. And finally, at the end of this section, I'm going to give you some exercises to put what you learn in practice. So there's a lot to cover. Now, let's get started. So what is automated testing? Is it a replacement for manual testing? Do I really need it? How should I do it? Should I write my tests first, which we call test-driven development, or should I write the application code first? Mosh, I don't know what to test. These are the questions that a lot of beginners to automated testing, as well as developers who have some experience, have in their head. So let's start with the first one. What is automated testing? Automated testing is basically the practice of writing code to test our code, and then run those tests in an automated fashion. So here's an example. Imagine we have this function somewhere in our application. It's a basic calculate function. It takes an input, and depending on some conditions, it returns different values. Now imagine this function is used somewhere in the application. With manual testing, we have to launch the application in the browser. Perhaps we have to log in first, maybe do a few clicks here and there to get to the target page. Then we have to enter values into a few form fields. So eventually, this function is called. Now this is very time consuming. This whole cycle to execute this function in a manual fashion may take 30 seconds of our time. With automated testing, we can write code and directly call this function with different inputs. And then we can run this code in an automated fashion. And this may take only a fraction of a second to test this function with different inputs. So with this practice, we can test a large part of our application's functionality and maybe the entire application in an automated fashion several times faster than a manual tester. Now here we've got this opinionated developer, Jasmine, and he believes writing all these tests is time consuming. Because not only do we have to write the application code, which we refer to as production code, but we also have to write the test code. So implementing a new feature with tests will take significantly more time as opposed to implementing it without tests. Because a part of our development time is spent on writing and maintaining these tests. So this is what John Smith argues. But is he really right or wrong? Well, let's see. Let's say we don't have any automated tests. As we add new features and our application grows in complexity, the time required to test all the application functions with various arguments increases exponentially. If you have worked in a large application with a lot of features that have been built over years, you know that sometimes no one in the team knows how these functions work and how they should be tested. Nobody knows the requirements. Because those developers who initially built those features are no longer a part of the company. So there are a lot of legacy functions around and nobody dares to touch them. Now, if we implement automated testing, we can test a large part of our application's functionality using automated tests. And the time required to do manual testing will be far less. In fact, some companies do not have any manual testing at all. They automate everything. Now, whether that's a good practice or not, it's debatable. But irrespective of that, some level of automated testing can definitely reduce the manual testing effort. But there is also one more benefit to automated testing. With automated tests, you can catch defects before releasing your software. And this can save you from a lot of nightmare. Have you ever been in the situation where you deployed the application to the production, you were happy, you went home, and then 30 minutes later, you got a call from your boss saying that a critical function in the application is not working. And then you have to log in remotely or go back to the office and spend several hours till very late at night trying to fix a bug. Most, if not all, developers have that kind of experience at some point in their career. Now, with automated tests, you catch more bugs before releasing your application into production. Now, I just want to clarify something here. I'm not saying that with automated tests, you're going to release bug-free code. That's not true. But what you release is often software of better quality. Now, as you talk to various developers about automated testing, you come across two extreme viewpoints. On one side of the spectrum, we have developers like our John Smith, who thinks automated testing is useless. On the other side of the spectrum, we have this guy who thinks you're not a coder if you don't write tests. What I want you to do is ignore both these extreme viewpoints. Instead, take the middle ground and be pragmatic. The reality is, even though automated testing has a lot of benefits, it doesn't fit every project and every team. For the starter, your team needs to have a discipline in writing clean tests and maintaining them. If you don't work in a team like that, writing automated tests ends up costing you more than the value you get out of them, because you will spend a lot of time fixing broken tests that are hard to read and hard to understand. In those cases, it's better not to write tests at all. Another factor is the time and budget of your project. Let's say you're part of a startup company and you have 3 months to turn a concept into real working software. In this situation, I argue that you should not spend your time writing tests initially because you don't know if this application or this business is going to succeed. Most startup companies have a small budget and they want to produce something quickly so they can show it to a mass audience and then attract venture capitalists to raise funds. If you want to spend 3 months writing tests, chances are your application may not even make it to the production. So what's the point of writing all these tests? Plus, in a lot of startup companies, the requirements change frequently. If you spend a lot of time writing tests, a lot of these tests break as you modify the application code to implement the new requirements. So in those projects, it's better to write tests only for parts of the application that would take more time to test manually. So use it as a practice to help you increase your productivity and go faster, as opposed to a hard and fast rule that you need to apply everywhere. Remember, the real world is different from books and courses. In the real world, we have constraints, and most of the time, these constraints are money and time. You cannot code forever. You cannot code for fun. Your job is to build real working software and solve a problem. Your job is to deliver value to the world. If you cannot deliver working software in time within the budget, nobody cares about all your fancy automated tests. So once again, I want you to be pragmatic and use automated testing when it makes sense. Even if you cannot practice automated testing in your current project or team, I strongly recommend you to watch this section thoroughly and learn automated testing because it will help you become a better developer. It will enforce you to write better and more reliable code. All right, Mosh, I got it. Now tell me, how should I write tests? Well, that's the topic for this section. So next, let's take a look at the different types of tests. All right, now let's take a look at the different types of tests. So in general, we have 3 types of tests: unit tests, integration tests, and end-to-end tests. With unit tests, we test a component in isolation without external resources like file system, database, API endpoints, and so on. Now, this is the classic definition of unit test, irrespective of Angular. In Angular terms, that means testing a component in isolation without its template and any other resources that touch the file system, the database, API endpoints, the browser, and so on. So if our component is using a service to talk to an API endpoint, we're going to give it a fake instance of that service. We assume that service is doing its job properly, and we just want to focus on the functionality of the component. Or similarly, if the component is using a router, again, we're going to give it a fake router, not a real router that works with the browser API to take the user to a different page. Unit tests are easiest to write, they're super fast, but they don't give us much confidence about the functionality of our application. So let's take a look at an example. Here we have this simple vote component that you saw in my beginner's Angular course. Now I've simplified the code here, but basically we have this property total votes, and this method that would change the value of this property. Now we can test this component in isolation. So we think of it as a plain TypeScript class, not an Angular component. So we don't care that it has a template. We just look at it as a simple TypeScript class. So this method is responsible for changing the state of this class. So we can call this method in our test and then inspect the value of the total votes property. If it's updated properly, that means this method is working. So writing this test is very easy, as you will see later in the section. However, if there's a problem in the bindings in the template for this component, we will not know until runtime. For example, if we forget to bind the click event of this button to the upvote method, our component is not going to function properly. And that's when we use an integration test. With an integration test, we test the component with external resources. Once again, this is the classic definition of integration tests. In the Angular world, that means testing a component along with its template. So instead of looking at this class as a plain TypeScript class, we need to look at it as an Angular component. And that means we need to run our test in an Angular environment. So we need to instruct Angular to compile this class along with its template. As you might guess, this kind of test requires a little bit more code than a simple unit test. There is some setup code because we have to put this class in an Angular environment. We need to deal with modules, dependency injection, and so on. However, we get more confidence about the functionality of our component. So this is integration tests. Now, if our component is using a service to talk to an API endpoint, again, similar to our unit tests, we want to give it a fake implementation. Now, in some ways, this looks a little bit like unit tests. And some developers can argue that this is actually a kind of unit test because we're still testing this component in isolation without a real service or a real router. However, I still see this in the category of integration tests because our tests involve testing a couple of pieces together, a component and its template, which is often in a separate file. So that's why I personally see this kind of test as an integration test, because we're testing the integration of our component class with its template. Now you may disagree with me and still think of this as a unit test, and that's perfectly fine. But let's not get hung up on the terminology. But for the rest of the course, I'm going to refer to the tests that involve the integration of a component and its template as integration tests, and tests that work with a component in isolation without its template as unit tests. Now we can write a few integration tests for this component, and all these tests may pass. However, when we run the application and use it like an end user, the application may still not work as we expect, because we're still looking at individual components, not the entire application as a whole. So that's when we use end-to-end tests. So with end-to-end tests, we test the entire application as a whole. So we simulate a real user. We launch the application in the browser, perhaps we log in, put in the username and password, click here and there, navigate to the target page, click on this upvote button, and then ensure that the total votes is updated in our HTML page properly. Now with this kind of test, we get a lot more confidence about the functionality of our application. However, these tests are very slow because each test is going to launch the application in the browser, navigate to the home page, then perhaps do a few clicks here and there to get to a target page and do something. So that's why these tests are slow. But they're also very fragile. A simple change in our HTML markup can easily break these tests, even if the application is working properly. So ideally, we want to spend most of our time writing unit and integration tests and write very few end-to-end tests only for the key functions of the application. But we're not going to test all the edge cases with end-to-end tests, like something being null, something being out of range, and so on. We use unit tests for those scenarios. So here are the three main types of tests. Now, as I told you, unit tests are easier to write. So in this section, we're going to focus entirely on unit tests, and then I will cover integration tests in the next section. All right, next we're going to look at the fundamentals of unit testing. All right, now let's take a look at the fundamentals of unit testing. The first thing you need to know is that tests are first-class citizens. So all the practices you have learned about writing clean and maintainable code applies to your tests as well. So here are some examples. your functions or methods should be small, preferably less than 10 lines of code. They should have proper names and they should have a single responsibility. The same principles applies to your test code. So each test should be less than 10 lines of code. It should have a proper name that perfectly describes what it's doing, and it should have a single responsibility. It should test only one thing. Alright, now download the zip file I've attached to this lecture. There you will find this new Angular project. In this project, we have these folders where I have included some code that we're going to use throughout this section. We start with very simple examples, and gradually, as we go through this section, the examples get more and more complex. Now, the first thing you need to do after you download this project is npm install and then ng test. So instead of ng serve, we run ng test. So this is going to build the application, and then it launches Karma, which is our test runner. All right, now back here, we want to write our first unit test. So in the fundamentals folder, here we have this compute function, a very simple function. If we give it a negative number, it returns 0. Otherwise, it increments the number by 1. You may think this is really so simple and it looks nothing like Angular. I totally understand that, but bear with me. We're going to start with very simple examples, and gradually these examples get more complex. So if you do have some experience with unit testing, feel free to skip the next few lectures depending on your knowledge. But if you're an absolute beginner, you need to look at all the examples. All right, now to create a unit test for this function, in the same folder, we're going to create a new file. Look at the naming convention, compute.spec.ts. So all our test files should have .spec.ts. This is the pattern that Karma, our test runner, is looking for. So anytime it finds files that match this pattern, it looks at the tests in these files and runs those tests for us. Now in the projects that we create with Angular CLI, we use Jasmine as our testing framework, which provides a bunch of functions that we use to write tests. The two functions that we use most of the time are describe and it. We use describe to define a suite, which is a group of related tests. And we use it to define a spec or a test. So let's see how we can use this. Describe. We give our suite a name, which is often the name of the system under test. So here we're writing tests for the compute function. I'm going to call the suite compute. Now the second argument here is a function that our test runner is going to call. So we can use this function syntax like this, or we can use the arrow function syntax, which is shorter and cleaner. So like this. Now here we have one or more tests or specs. To define a test or a spec, we call the it function. And similarly, we give it a name, test name, and a function. So this is the body of our test. This is what we're going to write, and our test runner is going to call this function, and then it will tell us if the test succeeds or not. Now, what should we call this test? Test name is a very bad name. It doesn't tell me what we're going to test here. But look at the implementation of this function. When writing tests here, we need to test all execution paths. So here we have two execution paths. One is for a negative number, and the other is for a positive number. So we need to write two tests here. So I'm going to change this to should return 0 if input is negative. Now you can read this as a spec of the compute function. It should return 0 if input is negative. All right, let's test this. So first I'm going to import this function from the top. Now here I'm going to call it with -1, get the result. Now we need to assert that this result is 0. To do that, we use the expect function that comes with Jasmine. So we expect this result to be 0. This is the API that comes with Jasmine. Now we have a bunch of other methods here. Let me show you. So we have to be defined, to be falsy, to be greater than, to be less than, and so on. So depending on what you're going to expect, you can call one of these methods. You're going to see more examples throughout this section. All right, now let's run this test. So save. Now, because Karma is watching our test and source files, as soon as it detects a change, it runs the test again. So here you can see it executed our test and the result was successful. Now, if you have a big monitor, you can put this terminal window on the side, and as you're coding and saving files, you can see if all tests are passing or something is failing. Alternatively, if you have double monitors, you can dedicate one monitor purely to your tests. It's much easier. Now, if you don't like this terminal window, you can see the report of your tests in the browser. So when you run ng-test, this will launch a browser window connected to Karma. Now here, if we click this debug button and open Chrome Developer Tools, on the console tab, you can see the list of all tests and their status. So here we have one test, compute should return 0 if input is negative. And you can see that this test is successful. Now let me show you what happens when the test fails. So back to our test code, I'm going to change this and say it should be 1. Save. Now in the terminal, you can see we have one failed test. And if we get back here and refresh this tab, look, our test failed. Expected 0 to be 1. Now if we click this line here, this takes us to the failed test. So here's the line where our expectation failed. Now back here, let's fix this test. Now we need to write the second test. So I'm going to select this test here. Hold down Shift, Alt, and the down arrow to duplicate the code. Modify the test name. Should increment the input if it is positive. Now I'm going to give it a positive number like 1. And we expect the result to be 2. Save. Back here, refresh. Beautiful. We have 2 passing tests. Next, we're going to look at testing strings and arrays. All right, now let's see how we can test strings and arrays. So in the second folder, arrays and strings, let's take a look at this greet function. So a very simple function. We give it a name and it returns welcome plus that name. So once again, I'm going to create a new file, greet.spec.ts. Now to save time, I'm going to copy a describe block here. Now, what are we going to test here? Well, we want to ensure that the name that we give to this function is in the output. So it should include the name in the message or the output. Once again, I'm going to import the function on the top. Okay, now back here, call greet, pass Mosh to it, and then we expect the result to be welcome Mosh. Now there is a problem with this test. This test is too specific. So if one day I come back here and I decide to add an exclamation mark here, this test is going to break. We don't want fragile tests that break often. So instead of checking for the exact message, I'm going to check for the existence of my name in the output. So I'm going to replace this with to contain Mosh. Now this test is a little bit more general. And if I change the message from welcome to hi in the future, this test will still pass. The same principle applies when testing arrays. Let's take a look at another example. So here we have getCurrencies, a simple function that returns an array of 3 strings. If I want to write a test for this function, I just want to assert that the result includes these items, US dollars, Australian dollars, and euro. But I don't care about their exact position. Because if in the future, I decide to change the order of these items in this array and sort them alphabetically, I don't want my test to break. So once again, getCurrencies.spec.ts. Now once again, I'm going to copy paste some code, but from the next lecture, you're going to have a spec file ready for you, so you don't have to type it from scratch. Here's our test suite. Now let's write the test. it should return the supported currencies. I'm going to import the function on the top and then call it here, get currencies, store the result here. Now I'm going to expect this result to contain US dollars, duplicate, Australian dollars, and euro. Their order does not matter. All right, from the next lecture, we're going to start testing Angular components. Now from this lecture, we're going to start testing Angular components. In each lecture, you're going to see a pattern that you see in a lot of real-world applications. So let's start with the first pattern. In the folder called Setup and Teardown, open this vote component. So this is a simplified version of the vote component that you have seen in my beginner's Angular course. You have a property total votes and methods that modify the value of this property. The pattern we have here is state change. So in a lot of components, we have methods that modify the state of the component. Now in a real world scenario, chances are after modifying the state here, we may use a service to make an API call to save the changes on the server. That's a different pattern, and we're going to get that later in this section. So for now, let's just focus on the state change pattern. Now back here, we have a spec file. Here we have some boilerplate code, so you don't have to write everything from scratch. Note that the name of our suite is vote component. That's the system under test. Now let's write a couple of specs. So this vote component should increment total votes when upvoted. So here I'm going to create an instance of the vote component. Call the upvote method and then expect that component.total votes to be 1. This is how we test this method. Now these 3 lines you see here represent a structure that you see in a lot of unit tests. We call this structure AAA, which stands for arrange, act, and assert. So the first line here is the arrange part, where we initialize the system under test. In this case, we're creating an instance of the vote component. The second part is the act, which often involves calling a method or a function. And the third part is the assertion. So as a best practice, to make your tests clean and readable, always put a vertical line between these lines. Like this. All right, now let's write the second test. So I'm going to simply select this, duplicate. We don't need this one here. All right, now let's change the name of the test. So should decrement total votes when downvoted. I'm going to change the call to downvote method, and then total votes should be -1. Now look at these 2 tests. These 2 tests have something in common, the initialization of our vote component. Now this initialization is only 1 line of code, and it's not a big deal. But sometimes when working with more complex objects, the initialization may involve a few lines of code. We can refactor these tests and move this initialization to a single place so we're not duplicating it in each test. So I'm going to cut this line here and move it inside the body of our suite. Delete and delete. Now each test is only 2 lines of code. However, there is a problem with this test. If we run this test, the second one is going to fail. Because in the first one, we're upvoting, so the value of total votes is going to be 1. And this means in the second test, the value of total votes is going to be 0, not -1. So the problem we have here is that our tests have side effects. The execution of one test can impact the execution of other tests. And with this, our tests will break quite often, which is really painful. We don't want fragile tests, remember? So how can we solve this problem? Well, when writing automated tests, remember, each test should run in an isolated world, as if it's the only test that exists in the world, nothing else. So we want to start with a clean state. How can we do that? Now previously, we didn't have this problem because we created this component inside each test. But now that we move this line inside the body of our suite, we have this problem. The solution is to use the before each function. So in Jasmine, we have another function called before each. As the argument, we pass a function here. And our test runner is going to call this function before each test. And this is a perfect opportunity for us to initialize our objects. So I'm going to change this. Set the type of component to vote component. So we'll have IntelliSense throughout this module. And then do the actual initialization here. Now in Jasmine, we have 3 other functions that are similar to before each. We also have after each, and it has the same signature. So it takes a function that will be called after each test. And this is a place where you do cleanup. Now in this case, we don't need to do any cleanup, but in your test, if you need to do cleanup after your test, this is where you add your cleanup code. We have 2 other similar functions, before all, which is executed once before all tests, and after all, which is executed once after all tests. So in automated testing terms, we refer to what we write in the before each function as the setup, and what we write in the after each function as the teardown. These are the terms that you hear in a lot of unit testing frameworks, irrespective of the language. Next, we're going to take a look at an example of a form. Hey, thank you for watching my YouTube video. My name is Mosh, and I'm a full-stack developer, a Pluralsight author, and a Udemy instructor with about 14 courses at the time of recording this video. So I've got lots of courses on both front-end and back-end development, including C#, Entity Framework, ASP.NET MVC, Angular, architecture, unit testing, and so on. This video you watched is actually part of my Angular course on Udemy that you can get with a discount using the link in the video description. And if you want to see my other courses, simply head over to programmingwithmosh.com/courses. You can also subscribe to my YouTube channel to get free videos every week. Have a great day, and I'll be back soon.